finish your test, maybe we should look at them before we get started. Talk about a few questions. And your score on here, you actually got 4 more points than what's on here. That's what's written there. What else we got? Who else? All right, so take a look at those. I'd say people especially had problems with some of those short answer questions towards the end, like those feedback diagrams. And the last question, I actually made the last one bonus. Last short answer one. The last number is your grade out of 97. No, I'm going to take them back. A few questions that I noticed people were missing a lot of. So the structure determines function. There's 2 of those questions. To get those completely right, you had to say what shape, like what kind of epithelium it was. Like the alveoli one, you could have said it's simple squamous, and that makes it easier for gases to diffuse because it's a narrow bit. And then, what was the other one? Which other one? Was it stomach? Is that the one that was on there? So you would have had to say that it's simple columnar because that helps. That's really good at secreting large amounts of stuff like HCl. So I don't know if those questions, you didn't have that in your study guide at all, that answer, but I got a lot of strange answers for those. And that's one you'll see more of. Like you'll see very similar questions to that. And then the feedback diagrams, people didn't do too badly. I noticed on that, the respiratory system one, I think a few of you read the question too fast, and you answered it as if the control center was broken and not working at all. When what it says is the control center is always active and sending signals, which is unfortunate because I think if you would have taken a little more time reading that question, you probably would have gotten it right for that one. So look over it. If you want me to tell you what was wrong there, let me know. Any questions? Want to talk about any of the questions? Wondering about them? Not so much? All right, so this is your first 202 test. So I always like to give you all some time for some feedback discussion business. Not with me because I'm scary, but instead with yourself. So with your group, you're just going to talk about these 4 questions. So how exactly did you study? Was it successful? What do you think you want to change for next time? And how can your group help you? Or how can your group work better together? Like maybe you feel like that first group you were in, I don't know, it didn't go so well somehow. Or there's some ideas where it could work better. Because the group stuff, that's when you get to practice those feedback diagrams and all the hard stuff. So maybe you've got some ideas. So we're going to give you a few minutes for that. I'm going to leave so you can talk about it freely. And then I need someone to pretend to be me for 2 minutes and elicit feedback from everybody. So who's the most bossy person in here? I'm not looking at you. Just looking around. All right. Okay. That's sexist, but whatever. That's fine. So apparently guys are bossy, I guess. So all Ross has to do is after, so it's 9:10, so I'm going to give you 4 minutes to talk about it with your group. So till 9:14, and then you're going to come up here and get the feedback from these 3 groups for these last 2 questions. So you get some suggestions from everybody. So listen to Ross, otherwise he's going to turn into the Hulk or something. He's going to turn into his brother. And then I'll come back at 9:17 then. We'll discuss a little more and then go on to 19 part 2. Proceed. I'll be back. Was Ross nice to y'all? No. He screamed. It's pretty terrifying. It's terrible. So the average was pretty low. It was a 68. It's not uncommon on the first test would be kind of low. 202 is a little bit harder than 201, just because it's more like systems, feedback. It's not just memorize these bones, memorize these muscles. Requires a little bit more thinking and a little higher level thinking than what you're used to maybe. However, as I mentioned to some people, I think, you can replace your lowest exam grade with your final exam grade. So it's kind of like you're starting fresh now. And now you kind of know what the tests will look like. So probably the biggest thing is if you didn't do well, you should probably change something about what you're doing for the class, either before class, after class, during class. You need to change something. Otherwise, what's going to happen? Probably same grades you're going to get. And I don't know, maybe you kind of noticed, oh, I didn't really think I needed to study those feedback things, or like some 201 person told me, I thought I just had to study the bold stuff and I'd be fine. There's no one in here, but you have to know the whole. What?
What's the point of the other stuff on there?
I didn't even know what to say really when they told me that.
Like, I just put them on there for 5 minutes.
Yeah, like,
Right.
what do
I
you?
just really wanted you to, work longer.
All right. And of course, I do have lots of office hours to help you if you're stuck on stuff. Monday through Thursday, or email. Before the first exam, I got, out of my 50 students, one person emailed me with one question before their exam. So, what? I know, and I was here. I don't know what happened. I know. I don't know what happened. I really don't.
Which email do you use?
Well, I got your email later. I think the one that's hooked up to my phone though is the @morgancc.edu one. So I get those quicker than the D2L ones, which I have to check on the computer. All right, so chapter 19, then part 2. Oh, I need your test back too, sorry. All right, so questions on the study guide? Yes.
I didn't even know what. Yeah.
Sure, so it's kind of like y'all did in the lab. So like if you're type O, what antigens do you have? You don't have any. If you're type A, what antigens do you have? If you're type B, type AB. There you go. So it's just saying what antigens people of certain blood type have. I probably could simplify that statement to say that. All right. And which of the following is the term for the mechanism to stop bleeding? Is it phagocytosis, hemostasis, immigration, or chemotaxis? It is hemostasis. Don't get that confused with homeostasis. It's like one letter difference, it seems like. When I first looked at this chapter, I actually read it as homeostasis. And I was like so confused for like a solid half hour. Like, what are they talking about? Anyways, so don't get confused. What is it when white blood cells leave the capillaries? It's immigration with an E. Which of the following is agranular? Is it neutrophil, eosinophil, basophil, or monocyte? It is monocyte. Those first 3 are the granular ones. And hopefully when we do our blood lab, is that tomorrow? We're doing tomorrow. You'll be able to see those granules in those white blood cells, as long as it works right. And what does someone who's type AB have that someone who's type A does not? That'd be antigens. And someone who's type O Rh negative, it's none. They don't have any antigens. So if you're not getting 4s and 5s on those quizzes, you really need to change something for studying. So if you don't know the easy stuff, you're going to have a hard time when you come in here for the harder stuff we're working on. Although I think most people did pretty well on that one, but if you aren't. All right, so part 1 was all about red blood cells and hemoglobin. Part 2 is about white blood cells and blood clotting. And one of the big differences is white blood cells keep their nucleus. They never lose it like red blood cells do. And of course, there's no hemoglobin. They don't carry oxygen. Instead, they're there to fight infections. They're your immune system, more or less. Kind of interesting how this works. So obviously, your immune system has to know which cells are yours and which things coming inside are not your cells. Either they're bacteria or there's some other foreign thing coming in. And they do that by using what's called this MHC protein. And the humans called HLA. And basically, that's a protein on the surface that has a shape that tells your body, this is my cell. They're different for each person. So like, maybe my cells have like that thing on there. And since Edith is in the front, she's got triangles on her cells. Like that. So it's kind of like antigens on the surface, like the type A, type B, but it's a little more specific even. So all of ours are different. Some of them are more similar than others. But if we just took your white blood cells and put it in my body would probably attack them, create an immune response. Or if we took somebody's organ and put it in me, my immune system would attack it, because these shapes would be different. And those shapes are the MHCs on there. So that's on your blood. That's on your white blood cells, and all of your cells that have nucleuses, which is most of the cells in your body. They've got this. Of course, the exception is the red blood cells, which have no nucleus, and that means they don't have MHC on there. What are the 3 main antigens they could have? Your red blood cells. So A, B, and Rh are the 3 main ones. There's some other minor ones, but we won't worry about them. I think we can just skip to the practice, because you did the stuff at home. You did the thing last week. One thing to point out is this word agglutination. So if an antibody to A sees the A antigen, it binds to it, and it creates like agglutination, which is like clumping of cells, which you kind of saw. Did they show up pretty well in the physio thing? The clumping? Okay, so that's what you'd get. In that table you filled out, you've got whatever type of blood you are, that's what antigen you have, and then you have antibodies against the other one. So whatever antigen you don't have, you have antibodies against it. So like type B, you have B antigens and anti-A antibodies. Type O, no antigens, anti-A, anti-B antibodies. Which is basically that table y'all filled out in the lab last time. Right? And to find out what the blood type is, you just simply take the person's blood, put the 3 different antibodies in there, anti-A, anti-B, anti-Rh in different wells, and see which one agglutinates, and that tells you what the blood type is. So that's shown in this one. It left off the Rh one, but blood types on the right, and the different antibodies. So if you're blood type A, you react with A. If you're blood type B, you react with B antibody. If you're A, B, both. If you're O, you don't react at all. So that's actually the H there, identify a blood type given the results of this test. So if this wasn't here, you'd be able to tell me what each of those blood types were. Be the idea. All right, so quick practice. And this one's on your own first. All right, so at this point, you should be able to do this without any notes or any help from anybody. Hopefully. Or at least try to. All right, so go ahead and check in with your group there, see if you all got the same answers. All right, so I know one place people are getting confused. And this always happens, don't worry. So for whatever reason, no one ever thinks this negative's like talking about RH. They always think it's talking about A, right? It's always RH. So you want to like draw yourself a line or something and say, like that's the RH, that's the ABO part. Because it sounds, right, like B negative, oh, it has no B antigens or something. Or B positive, it has B antigens. It's separate. You got to like, you know, kind of divide that in half and remind yourself what that minus or plus means. I think that's mainly where people get stuck. Or they try to go too fast. So what do you think the first thing you should think is when you see a blood type? What should you be asking yourself? So I think the easiest thing is to say, what antigens does it have? And write it down. And then once you do that, it's really easy to see what antibodies bind to it, right? Because you already wrote it down. But if you try to skip that middle step, you can easily confuse yourself. So step by step, and you'll have it. All right, let's take it a little bit farther. So Mr. Andrew has AB positive blood. So what type of blood can he receive from a donor? You have to think about this one a little bit, I think. All right, so why don't you chat with your group. And I'll tell you that A is not right. Is that 80% of you chose? So what's the first thing you're supposed to think about? Okay, so think about what antigens he has. So step 1 is what antigens that guy has, Andrew. And then step 2 is what antibodies he has. So if you can write that out. All right, so we got B and C. The answer is C. So if we start with what antigens does he have? He has all of them, A, B, or H. What antibodies does he have? So what antigens can he take then? Any of them. Because if he already is used to seeing these 3 antigens, then he could be given any of those antigens and his body won't react because he has none of those antibodies. So where'd y'all get stuck on these? Which of these questions? The second one? The last one? You probably got the first one right. Did you get stuck on the second one? Yeah, so
RH is positive, RH.
if he has RH antigens, it's positive. If you're AB negative, yeah. Well, let's do another one. Yeah, let's do another one. So AB negative, what antigens does that person have? What antibodies? So what blood types can they take? So the key thing is that they can't get any antigen, they have an antibody too. So can they take A negative blood? What about B positive?
No.
Why not? So they have the RH, right? Yes, so this person would be any negative. Right.
So then, why don't you rule out like an O with that?
All right,
That's where I'm being.
do you want to do O positive or O negative? O positive, okay. What antigens do they have? None?
They have AB.
Do they have A antigens? They have RH. So we have this right here. They have RH antigens because they're plus.
Oh, I thought that was the O. Just kidding.
What antibodies do they have? Yeah, anti-A, anti-B. And I should write anti on here just to remind you. So then what blood types can they take? They could take O positive. Can they take O negative? What antigens does O negative have on it?
Oh, no, it doesn't.
It's got no antigens.
So why can't? Whether it's positive or negative.
Right, because he has anti-A and anti-B.
But even though it has the RH.
Right.
So the antibody kind of overrules it.
Yeah, so anytime an antibody matches one of the antigens, you can't have it because your body would attack it.
Okay.
So then
Yeah.
It's the same thing if it was an O negative.
If it was O negative, what antigens does it have? What antibodies? No antibodies? What about RH? So then what blood type can they get?
Yeah.
only get O negative. But they can give it to anybody.
Right.
But it's not, even though they can only take one blood type, it's not really hard because they think O negative is popular. I guess that's what they give someone if they don't know this blood.
Right. But O negative isn't all that common. And I think you're, wait, did I put that in here?
It's like, it is pretty.
Yeah, I put the, oh, I took it out. Hold on, I don't remember the numbers. They actually have a picture. I guess it's not, yeah, the problem is the RH positive, it's like 85% of people have positive blood. And then only 45% have O. Yeah. So the best thing you do to practice this is just go, without looking at any notes or any help, just go through these steps for a bunch of different blood types. Just one at a time, until you kind of get it. Because it's kind of confusing. It's a lot of steps to put together. Are you kind of getting the steps, at least? Even if you're trying to... So yeah, just like the other thing, don't try to skip any steps. If you try to skip from blood type to antibodies, more likely to make mistakes than if you just go a little step at a time. All right, so next step, still related to blood type. That's called the hemolytic disease of the newborn. Probably heard of it at some point. And so with this one, it's a specific case. So if the mom's Rh negative, which isn't all that common anyways, and the dad happens to be Rh positive, which means the baby has a chance to be Rh positive too. And so obviously they take your blood type if you're pregnant. Is anyone negative here?
I had to get the program shot.
Okay, and they tested your husband though first, right? Or they knew his
At
blood.
this point, because sometimes they can't guarantee that that's who the dad is anymore.
Oh, wow.
They'll give it to you no matter what.
Really?
Yeah.
You're like, no, it's really my husband. They're like, we don't believe you.
He was like looking for any way not to give blood, and they were like, no, we're going to do it anyway,
Huh.
just in case. And he was
Interesting.
like, awesome. But yeah, so we had to do it no matter what.
Huh, interesting. Okay.
I guess
That
it's
is really-
Yeah, they said it's pretty common.
Yeah, now there is also a chance, which we talk about later, but if you were exposed to Rh from like a blood transfusion at some point, or there's some other rare thing, mainly it's from blood transfusions. And they figure they've got this drug they can give you that'll stop it anyways. So why not? So yeah, we'll talk about RhoGAM in a second. First, what happens if you don't do anything? You're Rh negative, the baby's Rh positive, and during birth or close to birth, it's very easy for blood to get mixed around in there. so the fetal blood to get into the maternal circulation. And of course, does the mom have antibodies against RH?
No.
She's RH negative.
So then, yeah.
So she would respond to the RH positive blood. Now, because it's only a little bit of blood right at the end, it doesn't hurt that baby because it's out. Like, it's not going to get damaged. But yeah, the next one, the mom now has lots of those antibodies because it took a while to make them. So if she gets pregnant with another one, those antibodies can cross the placenta, bind to the baby's blood, which is RH positive, cause the blood cells to lyse and cause problems like, their liver gets kind of overwhelmed taking care of those exploded blood cells, and there are some complications that happen. All right, so there's everything on a slide that I just said for you to have for your notes. So how's it prevented? It used to be somewhat common, but then they developed basically a good drug that pretty much prevents it completely. So in our country, it's almost, as long as you're getting prenatal care, it doesn't really ever happen anymore. So the way that works is if you are RH negative, apparently now we learned it doesn't matter what the dad is or anything. So they just don't believe you. So you actually get a shot that has antibodies to the RH antigen, which seems a little strange, right? Because that's what you were making, or that's what the mom would make anyways. But this is when you're pregnant the first time, and it'll bind to any blood cells that get into the mom and get rid of them. So the mom never makes the antibodies. Because if the mom never makes the antibodies, then you never have this second baby problem, because she never made those. So you inject these antibodies when you're pregnant the first time to get rid of the baby's fetal blood that leaks in there. So 28 weeks, 34 weeks, and after delivery, so 3 times.
Huh? You do it the first time.
You mean if you inject this?
No, without that.
They have like jaundice and some other problems, but it's not usually like fatal. But it could be, I think, in some rare
I
cases.
saw there was like jaundice being involved, but I didn't know. I'm like, that's not really that serious.
It kind of just depends, I think, on how many antibodies ended up going in there. But it's certainly, if you're at the hospital, I think most of the time it's not a huge deal, but it's not good for the infant to have to deal with like their liver being overwhelmed with dying blood cells right when they're born or when they're coming out. Where's my assignment? I think I put one on here for you to work on. All right, so try this one first. It's question 3. So try it on your own. So for each of those situations, do you think that infant would be at risk to get that syndrome, assuming no treatment was used? So just looking for a yes or no for each situation for number 3. All right, so check in with your group there for question 3. So they're all no. So which one did y'all think was yes? So the only situation where it could happen, if the mom's negative, first baby's positive, and the second baby's positive.
So would it affect the first baby?
No.
Would it affect
So is the second.
Yeah.
And it only fits the second one because they have the floating antigens, right?
Right.
Antibodies.
Well, the baby has the antigens, and the mom has the antibodies that go in there.
And then they're just floating in her stomach, right? The second baby, I guess. Right?
Would have been right if it would have been.
So no.
Yes.
Because see, the first baby was negative. So if she had a third baby that was positive, then that third baby would be at risk.
And then on C, it would have been at risk, the second one.
Yeah, she did.
No, because it's an RH negative, the first one.
But that one's negative.
And one kind of crazy thing, so my cousin's had 3 kids now, and she had the RhoGAM the second time, but it didn't work or something. So her 3rd kid had like a mild form of this, and they told her, you can't have any more babies because it'll be worse with the next one. And once you have those antibodies, there's nothing they can do about it. It's kind of interesting. I mean, she had 3, that's enough. Anyways, her kids are crazy, so. So which made me realize, I didn't realize that RhoGAM wasn't perfect, but apparently it doesn't work for every single person every time for some reason.
Because I know the first one they give you is to see if you have a reaction.
Yeah.
And they watch you, and then they did the second one, and then the last one afterward, obviously. Too. I have no idea.
Maybe make sure you weren't allergic to it for some reason, I guess, maybe.
They said the most important one is the one after.
Right.
And they said the ones before is just, to make sure you don't, and I was like, huh. But yeah, what do you do? I don't know. I don't know.
Well, if you did, they'd probably tell you no more babies.
Yeah, that's it, exactly.
Or test the baby's blood type after.
Right, and figure
And
out.
if it's negative, then it's
Yeah.
not a big deal.
Yeah, because you have to sit there. It's like, when you get flu shots and stuff, and you sit
Yeah. All right. So any questions on that? You got it? So what's the one scenario where it could happen?
It's both babies are positive.
Negative mom,
And negative mom,
2 positive babies or more.
which my husband is positive. So.
Oh, is he? Okay, yeah.
But apparently, all these scandalous women around here.
Well, if
But
you're,
I was in Kansas too,
yeah.
because when I was traveling with the twins, they said the exact same thing. They're like, you have to give it to you no matter what. And then I
It
actually
sounds
had the
like
babies
that
here.
scam from the drug company.
I agree. I agree.
Money,
'Cause
money, money.
it wasn't just here in Morgan that they told me that. It was we were in Kansas when I had.
And
the
they told you the
twins,
same thing.
And then moved here, and they were. It was
It's
all
a
the
good
same
way to
reason.
get people to take your drug. Well, your baby could die.
Dun,
Well,
dun.
give it to me, please.
Yeah.
Because you don't know who the daddy could be.
All right, so quick side note about bone marrow transplants, kind of interesting. Did we talk about this with sickle cell a little bit?
Yeah.
All right, so let's talk about with leukemia as an example. So what is leukemia an overgrowth of? White blood cells overgrowing. Of course, you know about this. So when you have leukemia, they can use chemotherapy, etc. But where do white blood cells come from? Where in your body? Your bone marrow. So all of your blood cells come from the bone marrow. If it's leukemia, you're making way too many of a certain kind coming from the bone marrow. So usually that means if you're going to get at the root cause, can you do surgery and take out the person's bones or something? With a solid tumor, that wouldn't make any sense, really. So instead, you've got to use strong chemotherapy radiation to kill all the bone marrow, basically, because that's where the disease is coming from. Is that a good enough treatment, or is there a problem with that? Kind of need your bone marrow, otherwise no red blood cells, no white blood cells. You'd probably be dead pretty soon. So after you get rid of the bad stuff, then you find a donor, and you could put the good bone marrow from someone else in there that doesn't cause leukemia or sickle cell.
For a bone marrow transplant, what has to be the same with your blood type?
So the blood type has to be the same, but also because your white blood cells come from there, you try to get as close of a match to that MHC we talked about at the beginning as you can. Right, exactly. And there's so many more types of that, it's much harder to find a close match. And so depending on how close they get, you might need to take immunosuppressive drugs for a while or forever. It's kind of interesting. Now, how do you think they get bone marrow from people? Okay, they almost don't have to do that anymore. So it's actually a lot simpler than it used to be. So they can give you some drugs that make your bone marrow stem cells leave the bone marrow and just float in the blood, and then they just take your blood out and collect the stem cells from it. Yeah. No, you mean if you're a donor? Is that what you mean? Or receiving it
So they pretty much just draw a lot of blood then, right?
from the donor? Yeah. They give you some certain drugs that make the cells leave, take your blood, isolate the stem cells, and then they give that to the person. Oh yeah, and I forgot. So they can also use your own stem cells that aren't cancerous.
So is that like,
That's a newer treatment that works really well because then you get your own cells back.
so like when they've been,
Yeah, in theory, yeah, definitely. Yeah. Yeah, isn't it like $5,000 or something? Yeah, I didn't do that for my daughter. Yeah, I know. Yeah. Sorry, you can't go to college now, baby, but we've got this cord blood for you. No, that's crazy. So yeah, that's kind of the idea for bone marrow transplants. And it sounds kind of easy, but you have to be in the hospital for like months because you have very low immune system for a while, and a lot of weird side effects can happen. Yeah. Did I mention that's where my sister works? Did I say that too?
Yes.
Yeah, so she's a nurse at Vanderbilt for a leukemia bone marrow transplant unit. Mostly it's like older people. So, and it's kind of rough because especially for like the older patients, she said like 20% of them don't make it. Like 30% of them or something. Which is kind of intense, you know, like you see someone come in and you know that there's a 30% chance they're not going to make it. So, and she moved from her first nursing job was working with long-term care facility for people with mental disorders that had intense like surgeries.
That's always fun.
So you've always quite a combination of things to deal with.
Someone with
Yeah, so she had all kinds of crazy stuff happening all the time, and it's kind of disturbing. So she actually likes this new job better. She had a lady hiding her dentures up her butt. Really disturbing. If you would like deal with that. All right, so anyways, that's bone marrow. So then the other parts of your blood are your platelets, we didn't talk about. And then, do you remember what are the proteins in your blood that do clotting? Those are platelets. I'm glad you brought that up. Thrombocytes is another word for platelets. But there's also little proteins that are smaller. That's the fibrinogens. So you have two things in your blood for clotting, the platelets and the fibrinogen, which are like little proteins that help. You'll see how that works in a little bit. All right, so your platelets are usually like the first responders. And they're formed in the bone marrow. And it's kind of crazy how they're made. You make this huge cell called a megakaryocyte, and then it breaks into 2,000 pieces. And each of those pieces is a platelet. Which is kind of strange, I think. So no nucleus, but they've got lots of little vesicles that contain clotting factors, basically. You'll see how those work, and cytokines. Make a little concept map so we don't get confused. All right, so if we start with hemostasis. Then there's three kind of steps. The first is vascular. If I could spell, it'd be better. What do you think vascular spasm is? Do I? Close. Yeah, so the smooth muscles in the walls of the vessels contract, and you prevent too much blood from getting to that spot. That's the first step. And then after that, so this is one. Next step is those platelets floating around. Make a platelet plug. And then after that, then you get the actual blood clotting. And I think a lot of times 2 and 3 are like mixed up or put together in your head. Blood clotting is actually happens after the platelets are there. It's kind of a separate step. And hemostasis involves all three of those. And in the platelet plug, it's got its own 3 steps. So it's got adhesion, release, and aggregation. I'm going to run out of room. So let's see what those steps look like. All right. So this is showing a pretty minor injury, like where you just maybe like scratched your skin and it's bleeding a tiny bit, not like some deep knife wound or something. So there's the vascular spasm, also known as vasoconstriction. And you can see these little purple things are your platelets. And one of the main ways you activate platelets is they stick to collagen. So your blood vessels are usually lined with simple squamous, right? So there's no collagen exposed because that's in the connective tissue underneath. But if you puncture it, now that connective tissue is exposed. So that's a signal for the platelets to stop and become sticky, to stick to it. And then the release is those platelets. They're full of chemical signals that they release. That's the release reaction. They're listed up there. And those signals bring more platelets to the area. And they adhere, those new platelets release, and that brings more platelets. So it's a positive feedback loop until the bleeding stops, basically. All right, and then we'll come back to that in a moment. Does that seem like that's a permanent fix? Just having some platelets stuck there? It's not. It's kind of the temporary. Let's plug that hole as quickly as we can. So which of these is not involved? All right. So it's impressive. You are right. It is D. So those other three things do happen. Vasoconstriction. One of the signals that's released is called platelet-derived growth factor. It brings platelets to the area, and it also tells the body to make more platelets. Oh, look what time it is. All right. We'll finish this next time. So all we have left is blood clotting to talk about. All right. All right. All right.